Alright, I'm going to try and solve the integral of 8 divided by the square of 4x squared plus 1. And the method for doing this will be trigonometric substitution. Specifically, x will be equal to some number times tan of x in this case. X equals tan theta. And we want to choose a such that a squared times that 4 becomes equal to that number, which in this case is 1. And so, in other words, we need a such that 4a squared is equal to 1. A equals to 1/2. We're going to substitute x equals 1/2 tan theta. So dx is equal to 1/2 secant squared theta, d theta. And now we plug this all into our integral here. So we get 8 times 1/2 secant squared theta, d theta, divided by 4 times 1/2 tangent theta squared, just becomes 1/4 tan squared theta plus 1 all squared. And the 4 times 1/4, that cancels out. And the 8 times 1/2, that just becomes 4. This bottom bit is now just tan squared plus 1, but that is equal to secant squared. So then this becomes secant squared theta d theta divided by secant squared theta squared. Now the square on the bottom cancels out the secant squared on the top, and actually there should be a 4 here. And so then our integral becomes 4 divided by secant squared, but secant squared in the denominator just becomes cosine squared in the numerator. So this is all equal to 4 cosine squared theta d theta. And I don't remember cosine squared theta off the top of my head, so we'll figure that out real quick. Cosine squared theta, doing integration by parts. Right. We'll pick u to be cosine theta, and du becomes negative sine theta d theta, and then dv then has to be cosine theta d theta, so that would make v sine theta. So cosine squared theta would then be equal to uv, so that's cosine theta sine theta minus the integral of sine theta times negative sine theta, so that just becomes plus sine theta squared d theta. And then you'll notice if we add the integral of cosine squared theta d theta to each side, this just becomes 2 cosine squared theta, the integral d theta, on the left. And then if we add it over here, cosine squared theta d theta, then these two guys combined become the integral of sine theta plus cosine theta d theta. And that's actually just equal to the integral of 1 d theta. Alright, so that means that 2 cosine squared theta, cosine theta, sine theta, and then 1 d theta is just theta plus c. Okay, but note that our original thing we were trying to solve was the integral of 4 cosine squared theta. So to get a 4 over here, we just multiply everything by 2. So 2 on the left, 2 on the right, and then 2 times c is just c. So we're not yet finished with this problem because we have the answer to the integral in terms of theta, but we need to get it back in terms of x since that's what we started out with. If you recall, x was equal to 1/2 tan theta, or tan theta was equal to 2x, so theta is equal to tan inverse 2x. Okay, we still don't know what cosine theta or sine theta are equal to, so for that we need our handy dandy triangle. So theta there. So tan theta equal to 2x means 2x goes here and 1 goes there. And then the hypotenuse of this triangle is just 2x squared plus 1 squared and the square root of that. So 4x squared plus 1. So then cosine theta is equal to 1 over square root 4x squared plus 1, and sine theta is equal to 2x divided by the 4x squared plus 1. So with all these little bits of information, we can now get to our final answer. I guess we'll write it out and then we'll do the algebra. 2 times cosine theta becomes 1 over 4x squared plus 1 times sine theta becomes 2x 4x squared plus 1, and then plus 2 times theta becomes tan inverse 2x, and then plus c. And then all nice and cleaned up, this becomes 4x divided by 4x squared plus 1, square and square roots cancel out, plus 2 tan inverse 2x plus c. And that's it.